this session we are going to discuss about the fugacity and fugacity coefficient. Okay. So fugacity means actually this is a word originated from Latin word by meaning of fleetness or escaping tendency. Escaping tendency or fleetness. This is called fugacity. Generally, this word used in the thermodynamics to study the behavior of the non-ideal gases such as carbon dioxide, nitrogen, CO2, oxygen, chlorine, fluorine, and so on. Okay. So, if you look at these two diagrams for the differentiation between ideal gases and non-ideal gases. In the case of ideal gases, partial pressure, this is the term used to measure the effective concentration of the ideal gases. In the case of the non-ideal gases or real gases, there is an effective partial pressure is there. There should be difference between partial pressure and effective partial pressure between ideal gas and non-ideal gas. Because ideal gas molecules don't have any inertial forces, any viscous forces, any interatomic forces. That's why molecules are arranged in a specific order in the cylinder. If you release the cap of the cylinder, the molecules moving in a specific direction. In the case of ideal gases. So that concentration can be measured in terms of partial pressure. Whereas non-ideal gas molecules, they do have inertial forces, viscous forces between the molecules due to interatomic forces. If you release the cap of the cylinder, the molecules will be moving like zigzag motion in turbulent behavior. Okay. So those concentrations cannot be measured by using partial pressure in the case of non-ideal gases. That's why fugacity is the word introduced in the thermodynamics to measure the effective partial pressure of the non-ideal gases such as oxygen, carbon dioxide, sulfur dioxide, nitrogen dioxide and carbon monoxide and so on. These are all the real gases or non-ideal gases. So mathematically it can be derived from the gas free energy fundamental property equation. If you look at the equation 1, at isothermal condition, this was discussed in the previous classes how to get this equation from the fundamental property equation to gas free energy equation. So from the equation 1, at isothermal condition, dt becomes a 0 so that we can get the equation 2. dg is equal to V into dP. If you apply this equation 2 for ideal gases, PV equal to nRT, n is equal to 1 mole of ideal gas, then we can get the V is equal to RT by P. Substitute V is equal to RT by P in equation 2, we can get RT by P into dP. dg is equal to RT by P into dP. So integrating on the both sides, we can get G is equal to RT log P. Integration of dx by x can be considered as log x. We can get G is equal to RT log P, where G called as molar gas free energy. There is a suffix indicates the superfix 0 indicates the molar gas free energy. Okay, let's say this is equation 3. So this equation 3 is valid for ideal gases to study the behavior of the ideal gases. Can you see some examples of ideal gases? Most of the inert gases, noble gases, argon, helium, xenon, radon, these are all the ideal gases. To study the behavior of the ideal gases, generally this equation 3 is highly used. In the case of non-ideal gases, so this equation 3 is modified into equation 4 for non-ideal gases. Just we are substituting in the place of P, F. F indicates the fugacity. Fugacity means effective partial pressure of the non-ideal gas molecules. So by subtracting 4 minus 3, you can get delta G is equal to RT log F by P, because RT log F minus RT log P, log A minus log B can be written as log A by B, so that we can get delta G is equal to RT log F by P. This is equation 5. So the ratio of F by P is called Fugacity coefficient. Here pi represents the Fugacity coefficient. It is also called as the ratio of Fugacity of an ideal non-ideal gas to the partial pressure of ideal gas at a constant temperature. This is called Fugacity coefficient. Pi is equal to 1 for ideal gases. Okay, if you substitute here pi equal to 1, F equal to P, that means if it is ideal gas, both are equal. Effective partial pressure and partial pressure both are equal for ideal gases. Right? Clear?